So this is the last method for solving. We have solving by graphing, solving by factoring, solving by quadratic formula, solving by completing the square. So say I give you, then we have one concept left, which is nature of roots, which we've kind of talked about already with the discriminant, which we'll do tomorrow, and then some word problems. All right. So solve by completing the square. So it'll say, example 1, solve the quadratic function So does that mean I need to use the quadratic formula? No. It says solve the quadratic function. If I just went with that, you could use any method I taught you. If it said solve the quadratic function algebraically, you could use any method but your calculator. Okay? If it says solve the quadratic function by something, you have to do that method. So by completing the square. So we just went over finding the vertex form by completing the square, and we stopped, correct? But if I say solve, we have to just keep going till we get x. Make sense? All right, so what if I give you a 9x squared plus 12x equals negative 4? 9x squared plus 12x equals negative 4. When solving a quadratic function, it doesn't matter if we do factoring, if we use our calculator. It doesn't matter if we use quadratic formula or completing the square. The very first thing you always have to do is get everything to one side and set equal to 0. Exactly. So that's my very first step. 9x squared plus 12x plus 4 equals 0. Now, it says solve by completing the square. So the only way we can solve by completing the square is to complete the square first. Okay? So, I actually want to change this because it's going to be a harder one to begin with. Let's make it be 18 instead of 12. You will thank me later. Do 18 for now. Why is this nicer? You have to take the 9 out of the first two. You would have to take 9 out of 12, which would have reduced to 3 out of 4. You would add a fraction dividing by 2 to get your, it's just a lot more complicated. Should you guys be able to do it? Absolutely. Should I start with that as your first question? Probably not. Okay, so that's why I changed it. So we want to complete the square. So what should we take out of the first two terms? A 9. And we're left with x squared plus 2x plus blank minus blank square bracket plus 4 equals 0. So we're doing nothing new right now. We're doing nothing new. We are completing the square. We were getting it into vertex form. We are doing nothing new than what we just did on that card. So we have to find our blank. Our blank is b divided by 2. b is not 18. b is what? 2. So we're going to go 2 divided by what always? 2, and then we square it. It's b divided by 2 squared. So it's going to be 1 squared, which is 1. I never skip steps because I like looking back here and knowing what my factors are going to be. Okay? So we know that 1 is going to become our blank. So then I'm left with 9 x plus what squared? What multiplies to give me 1 and adds to give me 2? X plus 1, right? Squared. What can we not forget to do? Multiply. 9 times negative 1 is negative 9 plus 4 equals 0. What do we do next? It's just completing the square. Nothing new at this point. Nothing new. Yeah. So the negative 9 and the positive 4 together, and we get 9x plus 1 squared minus 5 equals 0. And now we actually have it in vertex form. What's the vertex of this function? -1, -5. Is it concave up or concave down? Concave up. So is that a min or a max? Min, which means my range would be y is greater than or equal to -5. Remember, it's based on your minimum value. Okay? So we can answer all those questions. But did I ask you any of those questions? No. Did I ask you to put it in vertex form? No, I asked you to solve. And ultimately, solve means find what the heck the variable equals. Do I know what the variable equals at this point? No. So I need to get it by itself. So I need to do reverse BEDMAS. So what's the first thing I need to move? The 5. I'm going to add it over. So I'm going to get 9x plus 1 squared equals 5. What do I have to move next? You have to divide by 9 because we're doing reverse BEDMAS. And reverse BEDMAS is subtraction addition first, which we did. Then multiplication division next. Then brackets and exponents. So I can't move that 2, that exponent, until I've gotten rid of it, the multiplication that's beside it, right? Because it's reverse BEDMAS. So I'm going to divide by 9. So I have x plus 1 squared equals 5 over 9. Then what can I do? Square root it, because I have to get rid of the squared. And when I square root, what do I have to remember to do, guys? Do you remember? What sign goes in front of the squared? Square root. Plus, minus. So I'm going to get x plus 1 equals plus and minus square root 5 over 9. Why would we have a positive and a negative? Because we're going to probably get 2 x-intercepts, right? Now, remember back from grade 10. If you were given something like this, square root of 3 over 16, and your teacher asked you to simplify it, what could we simplify it to? You remember? Your teacher told you back in the day when you guys sat here and did the same look you're giving me right now, is that you can take that square root sign and split them. So we're going to get square root 3 over square root 16. Why would we want to do that? Square root 16 is 4. So it would actually work out to be square root 3 over 4. Right? And that's in grade 10. That's an aside. That has absolutely nothing to do with this question. I'm going to do that to you. Like, why is she doing that math on the side? Okay, nothing to do with the question. It's just proving to you that we can do that, right? So in our question, we have plus or minus square root 5 over 9. So what could we write it as then? Plus or minus square root 5 over 3. Exactly. Because the square root of 9 is 3, right? And then what can we do last? As was spoken, I will do that. Subtract 1. So you get x equals -1 plus or minus square root 5 over 3. Now this answer is good. It's a good answer. It would give me 2 x-intercepts, correct? It would give me -1 plus square root 5 over 3 and -1 minus square root 5 over 3. So I get 2 decimals, correct? It's a good answer. But sometimes they have the answer together, okay? So all you would have to do is make the one be a common denominator with the other one so you can put them together. So I would just change the -1 into 3 over 3. So this is just another option. I'd go x equals -3 over 3, because what's -3 over 3? -1. So it's the same thing as what -1 is. Plus or minus square root 5 over 3. What would possess me to do that? Now they're both over 3. So I can just write the top together. So I can write it as -3 plus or minus square root 5 all over 3. So this answer here is the exact same as that one. It just depends on which multiple choice you have. B, you're going to try this one on your own. X squared minus 21 equals negative 10x. X squared minus 21 equals negative 10x. What's the very first thing you guys are going to have to do? Add the 10x over, get it into x squared plus 10x minus 21, and then factor it? No. Put in your calculator? No. Use the quadratic formula? No. I asked you to do what? Complete the square, so you have to do. Now, some of you may have noticed this one's nicer than the last one. Why would that be? Yeah, there's no a value, right? There was nothing you had to take out, pull out of the first two terms. It was just a 1. When you divide a 1 over, it doesn't give you a fraction, which is nice. So we get x squared plus 10x minus 21 equals 0. You can take out a positive 1. X squared plus 10x plus blank minus 21 equals 0. So our blank is equal to 10 divided by 2 squared, which is 5 squared, which is 25. So we're going to get 1. Do I need the 1? No, but you can write it. X, look one back. So plus 5 squared. What if you forget to multiply them? Not a big deal because it's 1, but I do it anyway. It's just to practice, okay? Negative 25 minus 21 equals 0. X plus 5 squared minus 46 equals 0. Now, if I said put it into vertex form, you'd be done. If I asked you anything about the vertex, the axis of symmetry, the max, the min, the range, the domain, you'd be done, right? The only way we have to keep going is if I say what? Solve by completing the square. Okay, then I'd have to keep going. So I'm going to add the 46 over. So I get x plus 5 squared equals 46. Take the square root. When I take the square root, I have to remember the positive and minus. And I get x plus 5. Don't know why I'm writing in brackets. I'm going to erase that. Habit. X plus 5 equals plus or minus square root 46. Does 46 break into a perfect square to reduce? Like 46 divided by 4 is not nice. 9, 16. Okay. If it did break down into, this is a grade 10 thing again. I'm just going to show it over here. Don't think it's part of the question. So say it was square root 24 instead, right? I've used this example a few times. You could break that down into 4 and 6. The 4 comes out, it becomes a 2, so you'd have 2 root 6. You'd have to do that, okay? Now, if it says in exact values, can I run them down to decimals? No, exact values means once you have it in your nice little radical, stop the madness. Don't make it worse. Subtract 5. X equals negative 5 plus or minus square root 46. And now we're happy because we have it in x equals and I asked you to solve. Okay? So tomorrow, oh, I don't need to record that. So page 241, numbers 6 and 7. Tomorrow we're doing discriminant questions and some word problems, and we're starting a review. Okay?